All right, guys, let's do a few problems. So, so this problem says people buying food in sealed bags at high elevation often notice that the bags are puffed up because the air inside has expanded. A bag of pretzels was packed at pressure of 1 atmosphere and a temperature of 22 degrees Celsius when opened at a summer picnic in Santa Fe, New Mexico at a temperature of 32 degrees Celsius. Okay. The volume of air in the bag is 1.38 times its original volume. What is the pressure of the air? Okay, so what this is saying is, okay, let's say let's say a bag of chips is packed in Florida. What is the pressure of air in the bag? 1 atmosphere. Now, if you take it up in a plane, or if you go up to the top of a mountain, what will happen? The pressure around you is decreased, and so the gas will expand. Okay, so if you go to Denver, the pressure is 0.8 atmospheres. Okay, so the bag will expand. Okay. It's pretty neat, actually. So, one. I'm sorry? No, it's the pressure is decreased. In Denver, the pressures. So, PV equal to nRT. Okay, so roughly, if you keep the temperature constant, if the pressure decreases, the volume has to increase. Okay. It's actually pretty fun, and we were in Utah one time, and so we bought a bag of chips at sort of a lower altitude, and when we went to the north rim of the Grand Canyon, we went a couple of 3,000 feet higher, and you could see the bag of chips was bigger. All right, so when the volume of air in the bag is 1.38 times its original volume. What is the pressure of the air in air? Okay, so PV equal to nRT. So PV over T equal to nR. So if you're not changing the number of moles of gas, this will be constant. Okay, so what that means is P1, V1, T1. This ratio at 0.1 is equal to P2, V2, T2. Okay, so if the amount of gas is the same, no matter what you do to the gas, this ratio will be equal to that ratio. Okay, so initial pressure was that was the temperature, and that was the volume. There is the final volume. Okay, V2 is 1.38 V1. Okay, so P1 V1 over T1 . Okay, so P2 is T2 over T1 . Okay. What are the temperatures?
22 degrees plus 273.
Very good. Yeah. So you have to, in all these problems, the temperature has to be in kelvins. 305 over 295. And here, okay, we can keep that in 1 atmosphere, and that'll come out in atmospheres. So. 0.75 atmospheres. So I guess Santa Fe is higher than Denver. Mm. All right, so a cubic container of volume 2 liters. So here's a cubic. So let's say D, so the volume is D cubed. Okay, so the net force is what you're asking. Okay, P equal to nRT over B. So we'll calculate the pressure. The force is pressure times area, which is pressure times D square. D square is did everybody understand that? D is volume to the power 1/3, and D square would be volume to the power 2/3. Yeah? Okay. All right, now we can put in stuff. So the force would be 2 liters is so. Okay, so that's 1 liter. So 2 liters would be twice that, except that you have to think of it in a cube. So think of that, a Kleenex box, and we're going to calculate the force on one wall of the Kleenex box. The number of moles is 0.5 moles. R is 8.314 joules per mole per Kelvin. The temperature is 25, so 298 degree Kelvin. Volume is 2 liters. A liter is 10 to the minus 3 meter cubed. To the power 1/3. All right. 10 to the minus 3 to the 1/3 is minus 10 to the minus 1. So, and cube root of 2 is 1.25. So this becomes 0.126. Okay. So there is the force, and all the units that'll give you newtons. So that's 0.5 into 8.314 into 298 divided by 0.126 newtons. Is that a large force? So your mass is about 60 kgs. Your weight is about 600 newtons. So this is about 15 people. So the air exerts a force of equal to 15 people on that Kleenex box from the inside. So why isn't that box exploding? Equal and opposite force. So you take that box and throw it in space, that'll explode. Okay, if you had air in it and let it see. Yeah. Okay, so what is the gauge pressure in a 25 degrees Celsius car tire containing 3.6 moles of gas in a 30-liter volume? Okay. So we'll calculate the pressure, and our T over V. So 3.6 moles, R is 8.314 mole. Joules per mole per Kelvin. Temperature is 298 Kelvin. And the volume is 30 liters. And so this pressure will work out in pascals. Okay, that comes to the top. So So 10 to the power 5 pascals is 1 atmosphere. So 3 atmospheres. Okay. This is the absolute pressure. The gauge pressure is actual pressure minus atmospheric pressure. Okay, so, and 1 atmospheric pressure is 1 times 10 to the 5 pascals. So this would be 1.97 into 10 to the 5 pascals. And remember, 1 atmosphere is 15 psi, and so in your car tire, the pressure is 30 psi, which is gauge pressure. Okay. So this is slightly less than 30 psi, and so what do? You go to a gas station and you put some more air in it. Okay. So what will the gauge pressure be if you add 1 liter of gas originally at atmospheric pressure and 25 degrees Celsius? Assume the temperature. So you've added the gas and the volume remains constant. Okay, so what we'll find is, okay, what we want to find is how many more moles of gas did you add? Okay. P equal to nRT divided by V. Okay, so what we're going to do is you're going to increase the pressure. You're going to increase the pressure by increasing the number of moles of gas. You're adding more gas. You're keeping the temperature constant and the volume constant. Okay? The volume of the tire is constant. So increase in pressure is equal to increase in the number of moles. Okay. So now you just have to find the number of moles you added, PV or over divided by RT. And so you added the gas at 1 atmosphere, so 10 to the 5 pascals. You added 1 liter of the gas, 10 to the minus 3 meter cubed, 8.314 joules per mole per Kelvin, and you added the gas at 25 degrees Celsius. Okay, so the number of moles of gas you added was 100 divided by 8.314. So you added 0.04 moles of gas. Okay. And so the absolute pressure increased by 0.04 moles. (8.314 joules per mole per Kelvin), 298 Kelvin. And the volume of the tire was 30 liters. So the pressure increased by 3%. Okay, that's 3. This is 1 atmosphere, increased by 3% of an atmosphere by adding that much gas. Okay. So, and since the absolute pressure increased by that much, the gauge pressure also increased by that much. All right, we'll do one more problem. Some incandescent light bulbs are filled with argon gas. What kind of a gas is argon? It's a noble gas, so it's a monoatomic gas. What is the VRMS for argon atoms near the filament, assuming that the temperature is 2,500 degree Kelvin? Okay, so VRMS. All right, so here's the expression for VRMS, 3 kT over m. This little m is the mass of a single argon atom. Okay. Okay, that's equal to 3. We can multiply the top by Avogadro's number, and the bottom Avogadro's number, and now that's the molar mass, the mass of 1 mole of argon. Okay, and the reason I did that is because those numbers are easier to deal with. 8.314 joules per mole per Kelvin, and the temperature of the filament is 2500 degree Kelvin. And what is the molar mass of argon?
39.948.
Okay, so 40 grams, 10 to the minus 3 kg per mole. Okay. So VRMS, this will work out in meters per second. Okay, let's take care of powers of 10. So that's 10 to the 3, so, and 2.5 times 10 to the 3, another 10 to the 3 comes out. Square root of that is 10 to the 3, so this would be 10 to the 3 meters per second. Square root of 3 times 8.314 into 2.5 divided by 40. So VRMS would be yeah, 1.25 kilometers per second. Okay, what is the speed of nitrogen molecules in this room? Average speed of nitrogen molecules in this room? 500 meters per second. Okay. So this argon gas is a little more than twice the speed.